Against what most people think, humans are carnivores. In fact, ever since we've stopped eating this way, human health has suffered greatly. And this isn't just my opinion, the science backs this up. In this video, I'll show you the 6 main aspects of biology that proves humans are carnivores, and more importantly, why this matters for your overall health. In regards to dietary classification, there are 3 types of animals. You have herbivores, who primarily or exclusively eat plants, omnivores, who eat both plants and meat, and carnivores, who primarily or exclusively eat meat. One of the fastest ways to tell which group an animal belongs to is by looking inside, specifically at its digestive system. Firstly, we can look at our stomach acid, and this is surprising to most people. For any carnivorous species, a highly acidic stomach is essential. This is because meat naturally supports faster bacterial growth than most plant foods, so strong stomach acid helps ensure it can be digested safely without any risk of illness. Acidity is measured by a metric referred to as pH. The lower the pH, the more acidic it is. It is important to note that for every 1 point decrease in pH, it represents a 10 times increase in acidity. So a pH of 2 is 10 times more acidic than a pH of 3, and 100 times more acidic than a pH of 4. So, just how acidic is our stomach acid in comparison to other animals? Herbivore species that eat only plants with low bacterial risk typically have a very high pH level, indicating a low stomach acidity. For example, an elephant's stomach pH is between 6 and 7, and a koala has a stomach acidity of around 5 to 6. Omnivores who eat both plants and meat typically have a more moderate stomach acidity, typically somewhere in the middle. For example, pigs have a stomach pH of around 3 to 4. And baboons have roughly the same. Carnivorous species typically have very low pH, meaning very high stomach acidity. For example, tigers and wolves both have a stomach pH between 1 and 2. So, where do humans sit? Well, the human stomach has a pH of roughly 1.5, which is very indicative of a carnivorous stomach acid. As you can see, we have a very acidic stomach compared to omnivores and herbivores. To further illustrate how stomach acidity is linked to potential exposure of bacteria, we can look at one of the very few species that has a more acidic stomach than we do. Vultures have a stomach acidity with a pH of 1. The reason vultures have such an acidic stomach is because they're scavenger animals. They often eat the carcasses of animals that have been dead for a very long time. And as we all know, generally, the longer you leave something, the more bacteria builds up on it. So that's the first reason human biology shows humans are carnivores. We have a highly acidic stomach, similar to other carnivorous species, that is simply required for safely consuming and digesting meat. The next reason our biology shows we are carnivores isn't about something we do have, it's about something we don't have. In my opinion, this missing trait is one of the clearest signs humans are not meant to consume plant foods. What most people don't know is that every single plant, including all fruits and vegetables, contain a long list of toxins. This is because they are essential for the plant's survival. Every living organism's primary objectives are to survive and reproduce, so they must defend themselves in some way. Animals do this through physical capabilities, using methods like kicking, biting, or running. But plants are stationary, so they defend themselves through something called biowarfare. Biowarfare is the use of chemical compounds, or in the plant's case natural toxins, that harm, deter, or even kill predators when consumed. This is why all plants contain these toxins, because if they didn't have them, they'd simply be eaten by other organisms and die off. But in meat, there are none of these defense compounds. Now, these plant toxins aren't problematic if a species is adapted to them. For example, gorillas, horses, and elephants are hindgut fermenters. This means they have a specialized fermentation chamber in their large intestine or cecum. There, microbes break down plant fiber and neutralize certain toxins before they can be absorbed. Ruminant animals like cows, sheep, and deer have an even more advanced system, a multi-chambered stomach where food is regurgitated, rechewed, and fermented with the help of specialized microbes that can break down and detoxify a wide range of plant chemicals before absorption. Certain animals have other specific adaptations. Bees produce an enzyme called CYP9Q3 that breaks down quercetin, a plant compound that can cause oxidative stress and impair enzyme function. Goats host microbes that produce an enzyme called tannins. This breaks down tannins, which are a bitter plant compound that would otherwise interfere with digestion and nutrient absorption. But here's the thing. As we know, there are many of these different plant defense compounds in every single plant that humans eat. Even quercetin, the compound bees have adapted to break down, and tannins, the compound goats have adapted to break down, are in many common foods that people regularly eat. But we have no specialized digestive system to break these plant defense compounds down. We don't have a specialized stomach, we don't have any key enzymes, we simply lack the ability to break these plant toxins down. With saying this, however, we do have minor adaptations such as an enzyme in our saliva called amylase. However, amylase only breaks down starches into sugars. It does not break down the defense compounds themselves. Other carnivores such as dogs also have amylase in their saliva. But like us, they have no sufficient mechanism to break these plant defense compounds down. And when you look across the entire animal kingdom, there isn't a single herbivore or omnivore with as poor of an ability to neutralize plants' defense chemicals as humans. The only other animals that share this lack of plant processing ability are carnivores. That's why when consumed, these plant toxins cause damage. For example, glucosinolates, a defense compound found in many plants, including cruciferous vegetables like broccoli, kale, and Brussels sprouts. These can interfere with thyroid hormone production, decrease nutrient absorption, and cause oxidative stress, which triggers inflammation. Herbivores have enzymes or gut microbes to neutralize them, but humans, we do not. If humans truly were herbivores or even omnivores, we would at least have some method to break down plant toxins. So that's the second reason our biology shows we are carnivores. We have no adaptations to break down plant defense compounds, and therefore plants are problematic to us. The next reason our biology proves we're carnivores is the enzymes in our digestive system, and how differently they handle meat versus plants. When we eat, food is chewed. It then goes down the esophagus and into the stomach. But from here, digestion is very different for humans when it comes to meat and plants. In our stomach, we release a large amount of an enzyme called pepsin that breaks down protein, so some of the meat begins to be digested. Plant material, however, is largely resistant to this. It's made of tough fibers and complex carbohydrates like cellulose. Humans lack the enzymes to adequately digest these plant fibers, so much of it moves into the small intestine undigested. In the small intestine, meat continues to be broken down very effectively. Two enzymes called chymotrypsin and trypsin are released, which continue protein digestion, and digestive fluid called bile is released, which breaks down and absorbs fat. So in the small intestine, when it comes to meat, almost all of it is broken down and absorbed. But again, like in our stomach, our small intestine struggles with plant material. We also lack the enzymes here needed to break down key components of plants like cellulose, lectins, and many other plant fibers. So while meat is effectively digested and absorbed in the small intestine, much of the plant matter passes through undigested and moves into the large intestine. In the large intestine, again, a lot of this plant material can't be digested by us. So instead, bacteria here try to ferment it. But humans can only extract a small amount of energy this way. Studies suggest that less than 10% of the fiber we consume is actually fermented, so the rest becomes waste, often causing gas, bloating, and irritation as it moves through. Have you ever wondered why vegetables upset your stomach, or why you can see corn in your stool? Now you know why. In fact, due to this, vegans actually fart more. In this study here, they compared a high-fiber Mediterranean-style diet to a standard Western-style diet much lower in fiber, and it indeed found that the plant-rich diet led to 7 times more flatulence, which is the posh way to say they farted 7 times more than the people on the Western diet. What makes me laugh is that there are many vegan advocates online, and even the scientists behind this study, that are claiming that farting and having more waste is a good thing. Plantbasednews.com published the following quotes. Our Western idea that farting is a sign of being something wrong is totally false, and farting is a sign of a healthy diet and a healthy colon. These people are trying to claim that producing more gas and having more waste products shows their diet is optimal and a sign of true health. You know, me personally, I'm not so sure about that. From a survival perspective, it's the opposite. The ability to absorb nearly everything you eat of something is a clear advantage. In times of food scarcity, you need to be able to absorb everything you can get. The fact that we can absorb meat with such efficiency clearly demonstrates our biology is suited to deriving our nutrition from animal foods. Anyway, that's the third reason our biology suggests we are carnivores. We can absorb meat very efficiently, but have a very poor ability to absorb plants. Now, the fourth reason we can look at our biology and determine we are carnivores is due to the overall makeup of our digestive system. As we just talked about, humans can't ferment plant material in the small intestine. Our small intestine is built for breaking down meat, so any plant fermentation has to happen in the large intestine. And this isn't just us. In almost all animals, the fermentation of plants doesn't occur in the small intestine. For fermentation to occur in the intestines, it must be done in the large intestine. That's why the more plants an animal eats, the bigger their large intestine is in comparison to their small intestine. This gives them more room to ferment and break down all of that plant matter. When we look at humans, the small intestine makes up roughly 67 to 80% of total intestine length, leaving less than 33 to 20% for the large intestine. Lions are also small intestine dominant, with around 80% of total intestine length being their small intestine, and only 20% being their large intestine. But for chimpanzees, who are omnivores, roughly 50% of their total intestine length is their large intestine. Then for gorillas, which again are herbivores, the large intestine makes up about 77% of total length. As you can see, the more plant material a species eats, the larger their large intestines are. The short large intestine that humans have is why we have such a poor ability to ferment plants. We can only ferment around 5 to 10% of the fiber we consume. On the other hand, chimpanzees can ferment at least 50 to 65% of the fiber they consume, and gorillas can ferment at least 85% of the plant fiber they consume. This not only allows them to break down plant toxins and extract more nutrients from plants, plants, but it also allows them to extract more total energy. When fiber is successfully fermented, it's turned into short-chain fatty acids, which are absorbed and used as an energy source by the body. Fiber that is not fermented passes straight through a species and provides zero energy. Since humans can only absorb and ferment around 5% of fiber, a gram of fiber essentially provides us with 0 calories. But because chimpanzees and gorillas have much larger intestines that are better able to ferment fiber, they do get energy from it. For chimpanzees, each gram of fiber they consume provides around 1 to 1.5 calories. Since gorillas can ferment fiber even more efficiently than chimps, every gram of fiber they consume provides around 2 calories. So due to our intestine length, humans get close to 0 calories daily from consuming fiber, whereas gorillas get nearly 3,000 calories per day from fiber. That's the equivalent of 5 Big Macs every day. When you keep in mind that nearly every single plant found in the wild contains very little carbohydrates, fats, and proteins, and is mainly made up of fiber, it becomes very clear that because we lack the ability to ferment fiber, eating plants in the wild is essentially useless for our survival. The fact that we have a long, small intestine optimized for breaking down meat, and a short, large intestine with such a poor ability to ferment plants shows we are not equipped to consume plants. People like to argue that because we are primates, more specifically part of the ape family, it would make no sense for humans to be the only carnivorous ape. But as you can see, our biology is very different from that of other apes, and therefore our optimal diet is too. So that's the fourth reason our biology suggests we are carnivores. Our intestine length and function is that of carnivorous species. The next reason is due to the differences in nutrients we get from meat and plants. There are many nutrients that are vital to optimal human function that cannot be found in plants in any significant quantity, or in some cases at all. Examples include vitamin A, vitamin B12, creatine, carnitine, and taurine. Now, humans aren't the only species that need these nutrients to function. Herbivores, they also need these, but they've evolved ways to make them internally. Their gut microbes are actually able to create vitamin B12, and their bodies can produce creatine, carnitine, and taurine adequately from other plant-based precursors. For example, many herbivores, like cows and deer, convert a compound called beta-carotene from plant material into the active form of vitamin A, which provides them with all of the vitamin A that they need. On the other hand, humans cannot make B12 at all, and we can only make the other nutrients to a very limited extent. So in order to get the adequate amounts or optimal amounts, we must consume these nutrients from meat. There are also nutrients that exist in plants in supposedly very high quantities. However, we can't access them. For example, spinach is high in iron, yet we absorb as little as 1.4% of it. This is because plants contain a type of defense compound referred to as an anti-nutrient. These compounds work by binding with nutrients, blocking them from being absorbed. Spinach alone has at least 6 of these well-studied compounds. So not only can we absorb very little energy from most plants, but we also absorb very little nutrients from them. So that's the fifth reason we know we are carnivores biologically. We cannot create many nutrients on our own, and have either no ability or a very poor ability to absorb many of them from plants. The final reason we know biologically that we are carnivores is due to our anatomical makeup. We're the only species that can effectively rotate our shoulders and throw with power and accuracy. This allows us to throw objects a long distance with a lot of force. You can clearly see this in any Major League Baseball game, as well as with Aboriginal Australians, who have been reported to throw weaponry over 100 yards at animals they hunt. The development of a trait like this can only be explained by evolutionary pressure from hunting. This is something we can see depicted in cave paintings from 40,000 years ago. This trait also explains why we don't have massive fang-like teeth like many other carnivores. These animals need large teeth to kill prey and tear flesh from bone. We, on the other hand, kill and dismantle our prey with tools and strategies that require intelligence. Our smaller, sharper canines and incisors are built for chewing meat, not killing and dismantling prey. That's the final biological reason we know we are carnivores. Our anatomy is optimized for hunting. In this video, we've covered the biological proof that humans are carnivores. But what if our fossil records and history in general told the exact same story? Most people don't know this, but for the majority of human existence, we ate essentially only meat, and we were very healthy. But as soon as we added plants into our diet, we became very sick. This video right here breaks it all down and shows all the historical evidence that also shows how humans are a carnivorous species.